Welcome to another video where I talk about robotics technology that was obsolete 20 years ago. Today I'm going to be talking about one of the most requested designs that I've had on this channel since I started it, and that is the robotic head or solar tracker. These are a really popular robot. There's so many designs that have come out of the beam community over the years, and they're very versatile. They could be used from anything from a little stationary desktop toy to actually practical real-world applications like large solar panel arrays that track the sun as it moves across the sky. So let's have a look at some of the different designs, show how they work, and then we can look at building the simplest and most elegant, in my opinion, design out there. So let's get started. Probably one of the best functioning and most full-featured solar head circuit is the Powersmart solar head made by Wilf. Now this is a very interesting and elegant circuit, but it's quite complicated, as you can see. So we'll look at some slightly simpler ways to make similar circuits. So if we go back to the basic beam bicore here, so you have a inverter, capacitor, and those are coupled by a resistor here, and this will flip back and forth. And we use this tons for different circuits. But you can actually make this completely light sensitive by removing this resistor completely and then adding some back-to-back photodiodes here. Like that. This circuit will oscillate back and forth depending on which one has more light. So if this has more light, then it will spin one way. If the other has more light, it'll spin the other way. Now, if you arrange these correctly and attach this on a pivoting platform, they'll always want to balance each other out, and they'll hit a state where these are almost equally illuminated, and when that happens, they will flip back and forth very, very quickly. You'll basically have a very rapid AC current going to the motor, and nothing will happen, and this will stay staring at whatever light it is. So you can use this circuit. It works quite well. But we can make something even simpler and have even fewer components than this. So this here is the most basic solar tracking head circuit that I've found, at least. So how this works is it has a photodiode bridge. They go into an inverter. The output of the inverter goes into one side of a motor, and then the output also is split into the input of another inverter. So these will always be opposite, and they'll be dependent on this. So this will swivel to point at the light, and then when it's pointed, these will be almost equal, and the circuit will just flip back and forth really quickly, and it won't move anymore, at least in theory. So this is not my circuit. It's, I think, originally by a guy called Grant McKee, but I found it originally on a website called Simon Fraser something. It's an old website that has a whole bunch of beam circuits and some other interesting stuff. I'll put a link in the description below. This is how the circuit functions, but it probably won't work like this. You probably need a little bit more power coming out of these inverters than just one gate, unless you have a really tiny motor. So let's look at the full circuit built on a chip here. So this is the full circuit built up on the 74HC240 chip. Now these chips work really well. You can use any series, but for solar powered ones, especially I recommend the HC or the AC versions. Because they have a switching voltage which is roughly half the input voltage, which means that this will track light across a falling or a changing voltage supply, which is important for a solar circuit. As soon as the capacitor starts to discharge, the voltage will fall. If you have a fixed switching voltage here, your head will kind of tend to lean to one side as the voltage goes down. So let's look at how this works. We have the photodiode dividing bridge here, which goes into the inputs on one side of the chip, and these are all coupled together. Everything on this side of the chip is connected, so that is the outputs of these ones are all connected to the inputs of the other side. And then we have here a place to connect a motor. If you arrange this all correctly, you'll have a solar tracking circuit. Now, a couple things to note. The enable pins here have to be tied into ground. So if you're running this as a battery-powered circuit, well, you can just tie this directly to ground or through a small resistor. However, seeing as this is a solar tracking circuit, I feel like it should try and track the sun and power itself with that. So how do we make this solar powered? The original circuit I saw had a solar engine that interrupted the ground pin of this chip. That does work, but it's not ideal for a couple of reasons. Whenever you have a transistor, you're going to have a certain amount of forward voltage drop on that, about 0.7 volts. Now, there's actually going to be transistors inside of this chip, so we're going to be losing at least twice that inside of the chip before it gets to our motor, or around that, depending on how the insides of these chips work. So if we're interrupting it again, we're going to lose a lot of voltage, and considering this might only be running at 3 volts or so, well, there's not a whole lot of voltage to spare. Luckily, we can build a little solar engine circuit like this, so a Miller solar engine, and we can just couple that into our enable pins of our chip. So that means these are connected directly to ground and positive, and then the enable chip is connected to ground only through a transistor here. And then when it's not activated, when this is off, it'll be pulled up to positive with this resistor here. Now this makes for a slightly more efficient circuit, and it means that we can run our motor at a slightly higher voltage, which makes everything work a little bit better. Now I'll have all the values for these in the description, and if you want to see a more detailed build-up, I have a video about how solar engines work. Not pictured here is a solar cell and a large capacitor. I use two 4700 microfarad capacitors to run mine, but it depends on your motor. You might be able to get away with smaller or larger depending on what you're running. Let's go over to the breadboard and see how it works in action. So here we have the circuit built up, and it's just powered by two AA batteries here. And then instead of a photodiode bridge, I have a little potentiometer, and I just want to demonstrate how this circuit works. So when we power it on, you can see it spins one direction there. So if we look at our potentiometer, it will spin one way or the other depending on how that voltage divider is set up. Now you can see I've got the photodiode dividing bridge here. You can see by covering one or the other, it will change direction of the motor, and then that will want to track the light if we build everything correctly. Now one quick thing to note, if you build this and it ends up pointing away from the light, you just have to flip your motor connections around. And then we can actually look at how these solar sides work. So I don't have that built up on here, but by disconnecting the enable pin here and connecting that to positive, these are low enable chips, we can see it no longer functions. But by jumping that to ground, which is what our solar engine will do, we can see that it will then fire up and function. And then when that comes away, this will pull it up high and turn off our chip. And then that's how we can, a very easy way to solar power these logic chips. Instead of switching the whole circuit and wasting a little bit of extra voltage, we can just toggle this enabled pin up and down, and that means that we can turn off the whole circuit with only a tiny bit of current. Now they will drain, or they will draw a tiny bit of current even when they're not enabled, and it depends on the type of chip you have, but for something like this, it'll work very well. All right, now that we've figured out how this works, let's get started on it. I'll freeform this entire circuit, and we start with the main driver trip. So this is a super easy bit to freeform, as most of the pins on one side of the chip are all soldered together, so there's not too much complexity to that. After I was done bending those out, I bent the two enable pins together so it would give me an easier place to connect to. And then the other pins on the chip I just bent in kind of various groupings. So because we're ganging up so many inverters here, the circuit is kind of repetitive. You just have to pick which pins go where and then kind of group those together. Bent all of the pins, the kind of skinny part of the pins on the one side over, and then I'll just solder those all together instead of using a separate piece, which saves some time and give really tidy little look. I used an N20 gear motor for this, which are great little motors for stuff like this because you can actually solder to the brass gear housing. once I had done that, I soldered the ground pin of my chip to that entire assembly, and that gives me a place to kind of start building out the circuit from there. And then I connected the supply rails or supply pins of this chip to the motor directly, which gave it a little bit more stability as well. Although I do run the risk of ending up wiring my motor backwards, but I did test it beforehand and I kind of knew which way it was going to go where. I used some thinner wire to mount all of the photodiodes and run some extra power wires around, and that would just give me something to connect everything to, so I had convenient power rails and signal rails as I moved forward. I freeformed the solar engine as its own little part. The great thing about Miller solar engines is they are super easy to freeform and quite quick to do as well. And you can put them anywhere on the robot. I had a little bit of extra room on top of my motor, or kind of in the back part of the robot, and I just soldered in the Miller engine right there. Once all that was done, I wired up my solar panel, and then the main part of the robot is pretty much ready to go. I'm happy with how this turned out, and it has a pretty interesting little look to it as well. And I was able to find this little wheel, which is the same key as the gear motor shaft, and I was just able to push that on, and it gives it a nice little stable platform. Now that's the completed robot. Let's see how it works out in the wild. So that's it for this project. As you can see, these robots have tons of different versions, and there's a million different types out there that people have built, and I'll link some of my favorites in the description below. As always, thanks for watching. I'll see you next time.